Hello everyone, welcome to this problem. Today's problem is a bit particular because it was kind of difficult to understand. I do believe this maybe should be marked as hard, I don't know. But okay, let's dive into the explanation. So here you receive as input a string and you're supposed to find out what's the longest substring you can have in this string having an even count of vowel, and these are the vowel that you're supposed to take in consideration when making your computation. So let's say I have this for input, the answer is this, and we can clearly see that in this substring we have an even number of 2 of e, which is actually 2, an even number of I, which is 2, and an even number of o, which is 2. So now for me to explain this, I'm going to go with an incremental approach. So my first approach will be to share with you what is the logic if you want to apply that, just keeping in mind one vowel. So let's say I have this string. If I'm finding the longest substring I can have in this string containing exactly a vowel, an even number vowel. So I'm gonna start. If I'm to start here, I'm going to go incrementally. If I'm here, I would say the number of vowel here is actually 1. The number of vowel before this, I would say 0. This is the initial state. Initially, there's nothing. The number of vowel is actually 1 here. The number of vowel here, this substring, I mean from the beginning to here, is also 1. Also 1 here. Here will be 2. Here will be 3. Here will be 3. And here will be 3. And since I'm just checking for the number of even vowel, you do agree with me that having 3 vowel or having 1 vowel is actually the same. Having 2 vowel and having 0 is actually the same. So I'm just going to kind of a little bit erase my strategy here, and instead of 2, I'm going to put 0 back because it's actually what made. Maybe I should use a different way of using this so it will be better. So instead of 2, I'm going to have 0. Instead of 3, I'm going to have 1. And then here I'm going to have also 1, and I'm going to have also 1. This actually helped me to have only 2 characters for the creation of my various keys. So if you are here, you are actually 1. If there is nothing, it's a 0. Okay, so now one thing you should pay attention to, if I'm moving from the position element 0, this is where I'm starting before the beginning, from here. You do agree with me that from here we have an even number of A. We are starting at a position 0, and then we are here again at the next position 0, we have an even number of A. Let's say I'm taking this one from here to here. When I started here, I didn't count it because it doesn't exist. So when I'm starting here, I will also ignore this, the starting point, because it doesn't exist. If I'm from 1 to 1, the number of, like, the solution here is actually 1 because the size of the substring or the substring containing an even number of A is actually this one. If I'm moving from here, let's say what is the next? Let me take even from here. This is also a valid solution because, like I said, you ignore this. The solution B, C, A is a valid solution. So from this observation, I can see that if I'm moving from a position where I was having, if I have like a signature where I was having a certain number of A, the next signature having exactly that same key would construct a possible solution. And the goal here would just be to compute the solution and return with the maximum one, the one having the longest substring. And keep in mind that whenever I'm starting somewhere, I'm kind of ignoring the first character. So this is my starting point where there's nothing. If I'm starting here, I mean this is just the character I'm using. That being said, our problem is a little bit trickier than this because we don't have only A. We have A, we have B, we have A, we have E, we have all the vowel. Let us pay attention to this one and see if we can apply the same in this one. Now taking into consideration 2 vowel. This one we use 0 and 1, so we can use 1 bit to encrypt 1 vowel. So for this one, what we are going to do is that we are going to use 2 bit to encrypt the A and the E, because in this scenario we assume that we have only two vowels. So this one is going to be encrypted. We are going to start with the initially we are, let me take this color, it will be better. Initially we are 0 0, right? And then here we are 0 1. Okay, here we are 0 1. Here we have 0 1. Here we have 1 1, important, and here we have 1 0. And if you want to compute here what is the longest substring that we can have containing an even number of character, an even number of vowels. So for this one, this is like we just said previous, this is the first signature 0 0. Are we finding this signature somewhere else again? No, we are not finding it. This is 0 1. From year to year we have the same signature. So from year to year we have a valid solution, which is actually this substring containing of element B, which is a solution of size 1. This is another one. From year to year we have another solution 0 1. This is an error. This is 1 0. This is 1 1. Because we are 0 1 now, we update the E is the first bit, so we update this to 1. And this is also this is a 1 0 here, so this is okay. So this is a key, this is another key with the same value, so this is a valid substring, and the size here is actually a 2, and that 2 comes from the substring of B and D. And if you continue, we see that there is no valid solution, so this one the solution is actually 2. And this one the solution is actually from where to where. If you compute, you're going to see that the solution here is from B to C here, because we have a 1 year and then we have a 1 year, which are actually valid. No, from B to C. Why? Because we have a 1 year and then we have a 1 year, and since we ignore this, so the solution is actually this, which is 1 2 3 4 1 2 3 4 5 6. So this is actually a 6. So the two things you need to keep in mind here are, first, while looping, if you find a vowel, you need to compute the key of that vowel. And if it's the first time you are seeing that key, you need to store that in a map. And if it's the second time, you don't need to care about that. You may ask yourself why. Why? Because if here we have a 0 1 and here we had a 0 1, the substring taking this is account will always be shorter than the substring taking this in account, because whenever you're going to see this far away, if it's a valid solution with this, it will also be a valid solution with this, and this one will definitely be longer. So the first time seeing a key is all what you need. You don't need to add it multiple times. And the second thing is that for each of the values, even if it's not an element where you should compute a key, you should definitely compute the size or the solution at that position. Now, that being said, let's dive into the code. So the first thing I'm going to say, I'm going to have like a map where I'm going to store my various key. So I'm going to have map of string. I'll call it map mp. I don't know why I like to call it this way. And I'm going to have like my initialization point string. Current, I'll call it current key, which should be equal to, my current key is actually equal to my initial signature. Like I said, here I have 5 1 2 3 4 5. So it'd be nice to have like a 5-digit encoding 1 2 3 4 5. Now that I have this, the next thing I need to do is to have like my initial result. The result that is going to be 0. Result is going to be 0, and this is what I'm going to return here. Now here I need to put my logic. My logic will be for okay. So now for each of the elements, what am I going to do? So I first need to check if you are a vowel. I mean, if I can have like a vowel here, string vowel that is going to take A, E, I, O, U. So I'm gonna say if the v dot find s of I, that means if you are in different from string and post. If you're a vowel, there's something we need to do. We need to update our current key. there's going to be, I'm going to have something to compute key of my previous key, current key, and the character, that means s of I. I'm going to write a function for this. The function will help me to do what I was doing here, moving from here to here, moving from here to here. You see, when I move from here to here, I update the key from 0, 1 to 1, 1 because I saw a vowel. So the function I'm going to use will help me to do things like that. So when I'm computing the current key, what I need to do next is that if it's a new key, so I need to check if mp.find my current key, if mp.find my current key is actually equal to mp.end, that means it's a key that is the first time, it's a key that doesn't belong to our map. So in this case, I'm gonna insert it here. Map of current key is going to take I plus 1. Why is this guy taking I plus 1? Because when I started here, this is actually my index 0, where there's nothing. My first element is actually an element at position 1. So that is why an element at position 0 is actually taking key as if it's at position 1. And it will be easy for me to keep it this way to compute the distance. Okay, so now that being said, this is what I need to do whenever I'm finding a vowel. And in other scenario, I need to have something like this. So I need to take the max between the previous result and the result at this time. And the result at this time is actually the I plus 1, which is actually the position according to my map where you are, minus the position of the element with that key in my I would say my storage of keys. I guess it's okay. Now just need to write this function. So for this function, what we are going to do is that we are going to have a function called compute key. Compute key is going to take a string s and a char c. I'm going to call it c. In this string I need vowel, so better put this one a little bit up so I can use it both in my function and in my helper function. And here what I need to do is I need to find the index. Index is going to take my var.find of my character. Once I have the var, I need to check if s of the index is actually equal to -1, or not -1. If it's equal to -1, I need to flip it by saying s of index is now going to take 0, and else here what I need to do, I'm saying s of index is now going to take 1. And with this, I'm sure that this key is going to be updated with a new key that I need to have, and here I need to return s. Okay, what is happening here? Why is this guy complaining? Oh, this is strange. So it's working. Let us submit. Wrong answer. Oh, it seems like I'm missing something. Did I add this in my map? I didn't add this in my map because this first signature should be adding my map saying that mp of, like the first time we see this 1 2 3 4 5 is actually position 0. Yeah, so what was happening is that he wasn't considering that my first index. Oh, error of my. So this first index that we in fact our first initialization should also be part of our map. So not having this will kind of mess up with the result. Let us submit again. So now it's working, everything is great. So this is my approach of solving this. I hope you do enjoy it. Feel free to give me any input. I'll be really happy to interact with you regarding this. See you on the next video. Ciao.